Hello everyone, today we are here to answer a polynomial function. The polynomial function f of x equals ax to the power of 4 minus 3x to the power of 3 minus 63x to the power of 2 plus 152x minus b has one of its zeros at x equals 5 and passes through the point -2 and -560. Our first question was to use the given information to determine the values of a and b. Well, to do this, we first need to isolate one of the letters. I chose b because it was already on its own. To isolate b, I put the number 5, because it's one of the zeros, into all the x's. Once I have that, collect like terms and then move b to the other side to get it to be a positive. Your isolated b answer should be b equals 625a minus 1190. You can see that here. Now, to get your a, you're going to get your given point and input into the equation, -560 at f of x and 2 into the x sections. Then input what we got into b into the b place, so take out the letter b and input 625a minus 1190. Move all the numbers over to the other side to join -560. You should get -1218 is equal to 609a. Divide both sides by 609 to get a equals 2. Now, input 2 into your isolated b equation, b equals 625a minus 1190, and you get 60. Therefore, your a is 2 and your b is 60. This is shown here. The next question is to use the given information to state one of the factors of x. Well, this question is simple. We already know that one of the zeros is at x equals 5. Therefore, 5 is a factor, making it x minus 5 because of the reverse signs in the bracket, making 5 a factor, x minus 5 a factor. The third question is to determine all the other factors of f of x. Well, now that we have our a and b, make sure to input it into the original equation, making the only letter we don't know x. Then, the first thing we're going to do is figure out what number when put into the x slot makes the equation 0. Well, we know that x minus 5 is a factor, so when putting the number 5 into the equation, it should be 0, and it is. Next, we're going to perform synthetic division. To do that, we lay it out like this, where our number is here, and the numbers in the equation are laid out here. We bring each number down and times it by 5 until we reach 0. After synthetic division is done, we should get 2x to the power of 3 plus 7x squared minus 28x plus 2. Well, we're not done yet because it still needs to be factored even more. Then we look for another number that would equal our new equation to 0. Well, after some trial and error, we get the number 2, also making x minus 2 a factor. We perform synthetic division again, shown here, until we get 2x to the power of 2 plus 11x minus 6. Well, now that we have that, we can use decomposition factoring for this by getting two numbers that times to -12 and adds to 11. We got the numbers 12 and -1. After decomposing by using greatest common factor, we get 2x minus 1 and x plus 6. This means that the factors of f of x are x minus 5, x minus 2, x plus 6, and 2x minus 1, and make sure to add the brackets in between those. The following question was use the factor to determine the zeros of f of x. Well, that's easy because since we have all our factors listed, we just reverse the sign like we would normally. This means the zeros are x minus 5 turns into the 0 of 5, x minus 2 turns into the 0 of 2, x plus 6 turns into the 0 of -6, and for the last one, move 1 to the other side and divide each number by 2, isolating x, making the fourth zero 0.5. Therefore, all our zeros are 5, 2, 6, and 0.5. Our next question was to determine the behaviors of f of x. Well, we know the polynomial has a degree of 4, making it even, and the leading coefficient is positive. This makes the end behaviors as x reaches infinity, y reaches infinity, and as x reaches -infinity, y also reaches -infinity. Our next question was to determine the y-intercept of f of x. Well, to do this, all we do is input 0 into our x slot for the entire equation and see what we get. The answer is -60, so our y-intercept is -60. And finally, our last question is to sketch the final graph. When sketching the final graph, make sure you get all your 0 points. Each factor is on its own, so they all pass straight through the point and they don't flatten, pass, or bounce at all. Make sure you get your point in, which is -2, -560, which they gave before, and your y-intercepts, which is -60. Finally, our graph should look something like that. This. We have our going through our point, then we have our -2, 560, going through 0.5, going here, and it goes here, going out the same way because it was an even polynomial, and smiling because the coefficient was positive.